In this video, we will see what is a doubly linked list and how is it different from a singly linked list. What are its advantages and what are its disadvantages. So if you know singly linked list, you know that it's represented by two fields in a node. So first part is data, which contains the actual data, and it's called a linked list because it's a list of linked nodes. Nodes are linked among themselves. So let's say there are three numbers that I'm storing, 10, 20, and 30. And these need not be contiguous. So these may be at address 100. This may be stored at address 50 in the memory. And this is, let's say, at address 500. So we have the values there, and we have one extra pointer which stores the address of next node. So here 50 is stored because its next is stored at address 50. Similarly here 500 is stored. So in pictorially we can represent it with an arrow because it's storing the address of next. And whatever is the last node, there is no next to it, so its next is null. And we just keep the store the address of first node in some special variable called head. So head is a pointer which is storing 100. So we have just this value, and using this we can traverse the whole linked list. And in code we will represent it as a structure. So struct node, and then we have one data int and one node pointer which is next. And then we are given just one pointer, head. In this case, this will be pointing to this node. And using this, we can write head next. So then we will get the address of, we will get access to this node. Similarly, if we do next of this, we will get access to this. Now let's see what is a doubly linked list. So the same three numbers, 10, 20, and 30. We are storing the same three numbers, and let's say at the same addresses, 100, 50, and 500. So here instead of next pointer, we have one previous and one next pointer. So this is the previous, and this is still the same next pointer. So this will be storing 50, and there is one previous. So this node will also have info of what node is coming before it. So it will store 100 because its previous node is stored at address 100. Similarly, next and this previous. So this is storing 500 and this previous is storing this 50. And the next of last is obviously null. And the previous of first is also null because this is the first node and there is no previous. And again, we are storing the pointer to first node. So in code, there will be a slight change. So earlier we had int data, it's still there. Then we had a node pointer. Next, in the singly linked list, it's still there, but we have added one extra field. Previous. This was not present in singly linked list. It's in doubly linked list only. Now, why do we need to use doubly linked list? Why not singly linked list? So you see that here, if we have a singly linked list, 10, 20, and 30, same example. So in this case, if we are currently, let's say we are iterating the linked list, or we are given a pointer to some node in the linked list, let's say current, then we have this node has no info about its previous node. So if we want to find what is the previous node, we will again start from the head and store two pointers or keep comparing the next of the running pointer and see if it's equal to current, then this is the previous node and we will return this. But in the doubly linked list, we have this previous, we have this next. So if we are currently at this position, then if we do current next, we will know 30. And if we do current previous, then we will know it's 10. So we can move in both direction, traverse in forward direction as well as backward direction. This is not allowed in singly linked list. What are the other advantages? So first advantage was that traversal in forward direction as well as backward direction. So this was one advantage. Then the next advantage is that given a node, we can find the previous as well as next. So this is same as the earlier. And the next positive is that suppose we want to insert at second position, then what we will need to do, we will come at the second pointer, second position. So pointer will be pointing at second node and we want to, let's say, insert after second. So here its next will be the new node and its next will be this node. But let's say I have given you a pointer that insert a new node before current. Then how will you insert before? You don't have access to its previous node. So again, you will have to start from beginning. But here, if you are given some pointer, that I have a pointer current, which is pointing to some node in the linked list, and you have to insert a node just before that. So what you will do, you will create a new node and so make its previous, which was earlier pointing here, move this to this, and you have previous straight away. So make its next point to here and its previous here and its next here. So you are done. You don't need to traverse the entire list. Similarly, when you are told that or delete this node, the node pointed by a given pointer current. So what you will do, you know that current is pointing to 20. So you will find its previous and make its next point to 30. And you will go to its next and make its previous point to here and then delete this node. But the same problem if you are given that I have a current pointer pointing to some node in a singly linked list, delete this node. So you cannot simply delete it because it will break the list into two parts. You have to make the next of 10 point to 30 also. So for that you will need to know the previous node also given a node. So you will again start from the beginning and stop here, store the previous, make its next point to 30, then delete, and then you are done. So you see that deletion and insertion given a pointer is very easy in doubly linked list. So insertion, deletion is easier. Then next advantage is that in singly linked list, to reverse the list, you have to do quite a lot of effort. But in this case, you don't need to reverse at all. You just go to the last node, or you can also store it in a separate variable tail and just traverse it backwards. Print it, then print its previous, then previous until you reach the head. But you cannot do this in singly linked list. You cannot print its previous because there is no previous. You are just allowed to move in forward direction. So reversal not required. So this is another advantage. Now what are some disadvantages of doubly linked list? So the only disadvantage that you can see is that in the node we have data, we have next, and we have previous. Whereas in singly linked list, we had just these two fields. So you see that here there is one extra node pointer. So to store the same amount of data. Here we had three integers. So each node was taking a space of an integer and one pointer. But in this case, in the second case, the same information, to store the same information, we need one int and two pointers. So it's taking one extra pointer per node. But so this is the main disadvantage. But in practical applications, that will not look much of a disadvantage, because here you had just 4 bytes of data, and for that you were storing two extra pointers also. So it's comparable with respect to data. But in practical situations, you will store much more complicated data structures in a node, and that will not be just 4 bytes. That may be many fields inside that structure. So adding just one extra pointer will not seem to be a big overhead. So that's how we represent linked list, doubly linked list in memory. In the next videos, we will see how to insert data, delete data, and other operations in a doubly linked list.